Do you know the success trap of Agentic RAG? It's a cost associated with Agentic RAG. So how to control the cost? Let's begin a journey with NeuraArc. In this video tutorial, we will see how to control a cost while using Agentic RAG. So in the last video, we have gone through the Agentic RAG. We have seen how much accuracy can be achieved using Agentic RAG, and it's phenomenal compared to the traditional RAG. But moving the accuracy from 70% of traditional RAG to 95% of the Agentic RAG has a lot of cost associated with it. The costs is not a linear, it's a kind of a parabolic. So achieving 70% to 95% accuracy may be costing you 10x to 15x or 50x. So my last video taught you how to get accuracy using Agentic RAG. That means how to think. But this video will show you how much thinking costs to you. So the goal of this video is achieving agentic results at the price of traditional price. So why Agentic RAG costs more? And the answer is the operational shift. Because if you have remember the traditional RAG, that's a linear pipeline. And compared to Agentic RAG, it's a iterative feedback loop, right? So we will go one by one the features offered by traditional RAG against the feature of Agentic RAG, and we will understand what's the exact difference and where the costings gets differed. So in the traditional RAG, it is a one pass, right? So if you hit something, you will get out of it the output, you will generate it, your flow is done. But in the agentic RAG, it is not that way. When you try to retrieve, your critic, if you remember the node critic, it will loop through. If the answer is not sufficient or up to the mark or not be the sufficing the age of our confidence that has been given. So that is why agentic RAG is a loop kind of a thing where the context window for a traditional RAGs again fixed. We will ask top 5 chunks, top 3 chunks, and you have to iterate if you want a manual thing. But in the agentic RAG, it is not that way. It will keep expanding till the accuracy is achieved. That is why the costs gets adding to it. If you remember the earlier word or the pronouns this, that, those will add a loop in the agentic RAG, and that is why the costs will get increase. That is why it's an expanding nature inherently. Where if you come to the model usage, there is only one LLM associated with it to generate, that's the pro model. But in agentic RAG, you have different nodes, researcher, analyst, critic, right? So each node associates with the LLM. That is why you can say number of models are even increased. Number of LLMs are increased in the process of agentic RAG. And that is why the cost of the traditional RAG is a predictable, it's a flat, where the cost of agentic RAG is exponential and variable because you don't have a control. You need accuracy, but you don't have a control on the costs as such because process is not in your hand. It's the LLM who is doing everything for you. Right? So the things are redundant retrieval is the first problem. Then using a pro is the another problem. We will call it as a pro tax. And third is token blot. We will go one by one. The redundant retrieval means if agent asks one of the things from a DB and it again asks for the same thing, it will loop through it. The LLM will loop through the entire procedure. That's the redundant retrieval because LLM is controlling that one. You don't have a control as such. Then the pro tax. You have a different agents or LLMs have been used at different nodes for a critic, for a researcher, for analyst. So if all LLMs are pro, you are going to cost more. And then third is the token blot. Passing the entire script as an input to an LLM will definitely increase your costs because we know how many number of tokens have been consumed are directly proportional. So that's the third problem. Now, if we want to take an example, we will start with a classic example of the agentic RAG, which gives us the facility of referencing the earlier documents, like using some pronouns or word using earlier, right? So if I say this is the secret I mentioned earlier, the loop will start in the agentic RAG. So if it got the reference of earlier one, then if it again contains some reference back to the previous or more than the previous document, it will start looping it. But in the traditional RAG, it will not happen like that. You may have opted some basic overlapping chunking strategy and you will get the fixed set of tokens like 1,000 tokens. So your cost is almost nothing or it's a predictable one. But in the agentic RAG, as I said, analyst flags a gap, critic will trigger a loop, research will fetch the nearest neighbors. If you have more references to the earlier document, it will again go back to the loop and this is how it will process. So you are in no control how many tokens are getting processed by each LLM. So the cost is unpredictable. So the lesson is that we are here paying for a recovery and without optimization, achieving this accuracy is unaffordable because tokens will blot and you will be end up with a massive billing. So we will start with the concept of understanding how to save the exact cost. Where are the places where we can save the cost? And the first one is model routing. The simple thing, don't use very high, very pro, the PhD levels LLM for each and every node that you have. If your task is just to do chunking or just to analyze the things, we will see the severity of each and every node and then we will choose a LLM. The reason why I'm saying this because there are different costs associated to each type of LLM. The flash costs are just around $0.1 to 1 million token and the pro costs may be around $3.5 for per million token, right? So using a standalone or using same type of LLM everywhere doesn't make any sense. So these are the things where we can thought about it. Incoming tasks, right? So router analyzes the complexity. Then simple tasks, which where you are using the flash one, and the complex tasks, which are the pro. For example, the generation, where you can opt for having the pro kind of LLMs, where you are even prefer to get charged, but you are looking for the accuracy about the output. But formatting or fetching, you don't need that one, right? So the LLMs can be deferred for that one. So in the next slide, we will see the different nodes, how they are going to associate with the different types of LLMs. So this is the generator which is a common between the traditional RAG and agentic RAG, right? And in the both the places, we will definitely prefer the pro one for that. But the researcher, this is a agentic RAG node, right? Which acts as a librarian. It just fetches and manages the chunk. So we don't need a pro LLM over there. We will just use a flash model. The second one is analyst. Analyst is a kind of doing the strategy for you, right? So you will definitely prefer a pro over there because it is going to solve your cross reference things, and that is the main advantage of agentic RAG. So you will definitely go for pro. And the third one, again a critic. Critic is just checking the output. If it finds any logical error, not satisfactory results, it will ask system to loop through. We don't need the pro LLM over there just to check some conditions. So it can be achieved with the flash models. So this is how exactly the flash models and the pro models affects your costs and the way how you save the costs. So the next cost saving pattern is a semantic caching. If you remember in the earlier slide, we talked about there is redundancy or redoing the same task again and again if even the context is same, because in agentic RAG there is no standard caching associated with it. You have to provision that, and that is the second pattern for cost saving, that is semantic caching. If you have solved the problem already, don't pay it again to solve the same problem. So you have to choose a caching mechanism like a Redis where you can store those results. And when you get the same query back from the user, just fetch it from the cache. You will cost nothing for it, but you will get the same accuracy by caching the things. No need of looping the RAG again over here. If the cache is missed, definitely the standard LLM will get invoked automatically by your strategy and you will get the result. Till you have cache, no costs. And the third pattern is state pruning. This is very important one because many times you will find that the researcher will find 5,000 words and it will pass to the next level. But the entire 5,000 words are not required. So by analyzing those words through an agent, extract the exact related tokens, maybe around 300, 500, 400 kind of tokens. It, it will vary, but this is you have to process that one. You get the extract abstract out of it and then pass it for the next step. Using this mechanism, one of the thing that definitely you will reduce the cost and your context window will be reduced. And the context window is very important aspect in the RAG system because it is the most expensive agent who is generating the output, I would say like a writer in the entire ecosystem. So reducing a context window will drop your price by 90%. So in conclusion, there are three mechanisms to achieve the cost saving in the agentic RAG. First, or selecting the right model which you need for every node in your agentic RAG, the decision between the flash model and pro model. The second one is the state pruning, where you will not pass the entire context to the LLM. You will analyze it, get the abstract out of it, and then you will process it. And the third is a semantic cache. Don't pay for the same work, repeated work again and again. Get it at the $0 cost. Thank you. Stay tuned with NeuraArc for the next exciting video of multimodal RAG. Goodbye.